This video goes with the 7.1b Quotient ID and Rec ID. Solve for all values between 0 and 90 degrees. So we're just going to look at a couple of sample problems. What we've done in the past is looked at triangles where they give us the side lengths, or they give us, like say, two of the side lengths. We have to find all the ratios. What they're doing now is giving us the triangle side information encoded in the functions that they're giving us, and we might have to deal with quadrantal angles from time to time, or special right triangles. Just have to see what's involved in the problem. So let's look at, say, number 2. So it says that if cosine of an angle is root 2 over 2 and the tangent is 1, find the sine of x. You should remember something about root 2 over 2 and 1 from our 45, 45, 90 triangles, and it wants to know then what the sine of x is. So let's say that we didn't remember about the 45, 45, 90 triangle. Then what they're saying here is what we want to do is we want to sketch a triangle, and it tells us that the cosine is root 2 over 2. So that means the adjacent side over the hypotenuse is root 2 over 2. Root 2 is the adjacent side, and the hypotenuse is a 2. Now it tells us that the tangent is 1. Tangent is opposite over adjacent. So we got O over A. This was adjacent over hypotenuse. So using this angle, we've got adjacent over hypotenuse for cosine. It says that tangent is opposite over adjacent. It comes out to be 1. So if this ratio comes out to be 1, that must also be a root 2. And that gives us opposite over adjacent of 1 and cosine of root 2 over 2. And it wants to know what the sine is of the angle. Sine is opposite over hypotenuse. We got root 2 over 2. So sine of theta is root 2 over 2. Now if you remembered from this pattern that we have a 45, 45, 90 triangle where we got that 1, 1 radical 2 set of basic side lengths, you should remember that a 45 degree angle has a root 2 over 2, and for the sine, which is 1 over root 2, you have to rationalize it, and we get root 2 over 2. So that would have been a shortcut if you remembered that. Let's look at another one. Let's look at, say, number 4. See what's going on with that. These are all kind of mixed in together. Okay, but we want to try to use the same strategy if we can. Here we have a sine of 8 over 17, and cosine is, and cotangent is 15 over 8. So we want to label this information. Now cotangent is the inverse of tangent. So if cotangent is 15 over 8, tangent must be 8 over 15. And we want to use that to set up the triangles. Tangent is opposite over adjacent. It's telling us that sine is 8 over 17. That's opposite over hypotenuse. So we want to draw a triangle with those dimensions. We'll let this be our angle. For the sine, we have opposite, which is 8, over the hypotenuse, which is 17. For tangent, we have opposite over adjacent. The adjacent must be 15. And it wants us to find the cosine. Cosine of the angle, well, they're using actually alpha. Cosine of the angle is adjacent. There's the hypotenuse, adjacent over hypotenuse. Cosine alpha is 15 over 17. So what we did was we used the cofunctions, or we used the cofunction of tangent to figure out what tangent was, and opposite and adjacent, and we use that to label the sides of the triangle. Let's look at one more. Let's look at number 7 on this side. Okay, so it's telling us that the cosine of beta is root 21 over 7. Negative root 21 over 7. and the sine is negative 2 root 7 over 7. So and they want us to find the cotangent, which means we have to find the tangent and flip it over to find the cotangent. Now, also, I recognize that this has been rationalized. So this was actually negative 2 over root 7. So, and then when we rationalize that by root 7 over 7, it simplifies to negative 2 root 7. The other thing going on is that we have a negative for the side lengths. So that means that this triangle is actually going to be oriented into one of the other quadrants, and that's going to influence possibly the sine, cosine, or tangent values that they're looking for. So I want to try to think about where the terminal side is. I'm going to draw the quadrant system here. Now it says that the cosine is beta is negative root 21 over 7. So adjacent over hypotenuse. The hypotenuse is a 7, and the cosine is a negative root 21. So negative x's, which are the adjacent sides, are going to be in either the third or the second quadrant. It tells us that sine, which is opposite over hypotenuse, is negative 2 over root 7. So it means the opposite side, which is the y, is a negative. So negative y's are going to occur in the fourth quadrant or in the third quadrant. The place where both of these are together is going to be in the third quadrant. So this triangle actually should be drawn in the third quadrant. So I'm going to draw the triangle in the third quadrant. The angle is beta. And now I can fill in the information. Cosine is adjacent over hypotenuse. This is root 21. It's actually negative root 21 for the coordinate down here of the x. The y coordinate is a negative 2. That means this length here is a 2. And they're telling me that the hypotenuse is a 7. So the hypotenuse is a 7. And they want me to find cotangent. So I need to find out what tangent is. Tangent is opposite over adjacent. So my opposite side is a 2. My adjacent side is a root 21. So I get 2 over root 21. Now, in the third quadrant, using ASTC, I see that tangent is positive in the third quadrant, so this stays positive. And they want cotangent, so I'm going to invert 2 over root 21 rather than simplifying it. Since they want cotangent, this is going to be root 21 over 2. And again, it's positive because in the third quadrant, tangent is positive. Let's do a couple on the other side of the page. Over here, mixed review, solve for all values between 0 and 90 degrees. Really more of the same. Let's see, you can see with, like, say, number 9, that the 13 is the hypotenuse, opposite side is a 12, adjacent side is a negative 5. So let's do that one. Let's see which quadrant it's in. The sine is a positive because the 12 is the opposite side, which is a positive, so it's going to be in one of those two quadrants. But the cosine is a negative 5, so the adjacent side is a negative 5. Negative cosines are going to be where the x is negative on the x-axis. So the place where they're both true is going to be in this quadrant here. So this triangle needs to be drawn in the second quadrant. My angle is theta. My opposite side is a 12. My hypotenuse is a 13. The adjacent side is a 5. This coordinate is actually negative 5 for the x and 12 for the y. And they want me to find tangent. Tangent is opposite over hypotenuse. Opposite is 12. Hypotenuse is 5. in the second quadrant using ASTC. I see that only sine is positive in the second quadrant, so tangent must be negative. So I stick a negative sign on the tangent. And that's that one. Let's look at number 11. I'm just kind of randomly jumping at some of these. It tells me that the secant of theta is 0. Now secant is cosine inverted. So if the secant is 0, that means that since secant is hypotenuse over adjacent, the adjacent side must be a 0. And the hypotenuse really could be anything. So the cosine of theta, the cosine is secant flipped upside down. I could think of a 0, say, coming out from like a 0 over 1, which means that cosine must be 1 over 0. Therefore, cosine would be undefined because you can't have division by 0. And let's do one more. Let's look at 15. So 15 says secant is root 10 over 2, and they want us to find the cosine. So secant is cosine flipped over. So if secant is root 10 over 2, cosine y must be 2 over root 10. And we basically got the answer, except we have to rationalize the denominator by multiplying by root 10 over 10. So we get 2 root 10 over 10. 2 and 5 are both even. 2 and 10 are both even numbers. So we get root 10 over 5 when we simplify that. And that's about all we have for the examples on this page. Let me know if you have questions on any others.